the urban areas to other areas. Agricultural regions, it may connect agricultural regions, resource development areas, and remote outposts. Now, look, you can look for the meaning of each one of them. You can Google them, but I will give you the main concept. The main concept is two-lane highways are used to connect smaller areas to other areas, or less populated areas to more populated areas. This is the main function of two-lane highways in the rural areas, to connect less populated areas, which are normally the boundary areas, agricultural regions, remote towns and community centers, to more populated areas, other cities, other communities, and so on. Okay. Now keep in mind, although it is not written here, but we are still talking about rural two-lane highways. Two-lane highways in rural areas. Why? Because we are still talking about uninterrupted flow facilities. So these are uninterrupted flow two-lane highways. So they can only be in rural areas. Why? I already gave you the reason earlier as well. Because in urban areas, two-lane highways are provided in residential areas. Then you cannot make them uninterrupted because it will be dangerous. It will have high speed and it will be dangerous. Okay. So we are talking about two-lane highways in rural areas, all of them. According to Highway Capacity Manual, two-lane highways can be divided into three classes. Rural two-lane highways can be divided into three classes. Class 1 are those highways which are designed for higher speeds. They are normally used for connecting different cities to each other. Their functional class is arterial, and they are used mainly by daily commuters, people who travel daily between different cities. They will use class 1 arterial. They are mainly serving the mobility needs of the people. Mobility means the ability to move. Okay, so ability to move is increased when you have higher speed. Okay, so this is why they have higher speed, because they are serving the mobility of the people. Okay, so in order to maintain higher speed, then you have to design the highway accordingly so that the high speed is maintained. So the geometry of the road is gentle and smooth and mild. The radii which you are using, the gradients which you are using, they are very mild and very smooth, so that people can go over them at high speeds. Provided in addition to that, you also use shoulders, recovery areas. Shoulders and recovery areas usually increase the comfort of the drivers, and then they can go at high speeds. So to maintain high speed, shoulders and recovery areas are also important. Okay, so they have shoulders, recovery areas, they have markings and signs. So basically they have all the accessories which are required to maintain high speeds. Okay, then we have class 2. Class 2 is used for low speed travel, and they are usually designed for connecting remote areas, for example, for access routes, and for connecting scenic and recreational facilities. For example, you have a beach somewhere, you have a farmhouse, or you have a picnic area which is in the outside the city. So that area may be connected by a class 2 highway. Okay, so obviously those areas, or the highways which are going towards those areas, they don't have high speeds, because the main function is to get to that area without endangering someone. Okay, so they have low speeds, and they are basically there, or they are designed for connection of that area, access to that area. So their purpose is not to have high speed, their purpose is to just provide the connection. And since they are connecting these scenic and recreational routes, so they mainly go through rugged or rough terrain. Rugged, rough, sharp terrain, like you can see in the picture over here at the bottom. So mountainous areas usually mountainous areas are usually rugged terrain, right? But at the end of the mountainous area, you will find many beautiful places for picnics and relaxation. Okay, so we want to go for relaxation, but the highway which will take us there will pass through most of the time rugged terrain. Even if you go to beach areas in Bahrain, you will find that the highway which is going towards that area is mainly passing through a very rough terrain. Okay, because the area is not so much developed, right? So terrain is usually very rough. So it has low speed operation, and then in that case, the sight distance is also not good. In rough terrain, in rugged terrain, sight distance is not good. It's very expensive to maintain large sight distance in those areas. So if you don't have enough sight distance, then passing cannot be allowed. Passing cannot be allowed. So in most of the class 2 highways, passing is not allowed because of the sight distance. Okay. And then because you are maintaining low speed and you have rough terrain, so you may not see shoulders, you may not see much markings or signs. Okay, the pavement itself is made up of low type. Okay, because you don't want to maintain high speed, so it can be allowed. Having no shoulders and having just little bit of marking and signs is allowed. Okay, if you want to maintain high speed, then all these things must be provided. Then we have class 3 highway. Class 3 is an exceptional case, a very rare case, and which is only adopted by a few departments of transportation, like Florida Department of Transportation, and they are provided in the developed areas, in the small towns and small villages. They serve as the main street. Okay, in a small town and communities, they serve class 3 highways, serve as a main street, their main street. Okay, so they are very similar to class 2, but they are provided in developed areas. They are similar to class 2, but they are provided in developed areas. So their terrain is better, but still they have low speed, the sight distance is not so good. They have unsignalized junctions, unsignalized intersections, and they may have driveways on their sides. Okay, and they may go towards recreational areas within the small towns. Some of the class 3 highways may go there as well. Now, what is the link of different classes of 2-lane highways to the functional classification of the highway? So we know the functional classification is local roads, collectors, and arterials. Okay, so what type or what class of 2-lane highway can be a local road? What class of 2-lane highway can be a local road? We have class 1, 2, and 3. What can be a local road? Class 1, 2, or 3? Tell me. What class of highway can be a local road? Class 2. Okay, yeah. Anyone else has any opinion? Any other opinion about it? Class 2 highway can be a local road. Yeah, fine. Class 3 can be a local road. Yes, class 3 can be a local road. Usually it is not the case. Class 3, because it is the main street of that area. So usually class 3 will not be a local road. Okay, usually this is the case. So class 2, class 3 is not mentioned because, as I said, class 3 is an exceptional case. So this is why it's not mentioned here. Class 2 is mentioned. It can be a local road, and class 3 can be a local road as well. Okay, it's not impossible. And rural collector can be class 1 and 2. What about arterial? Which class can be arterial? 1, 2, or 3? Which class can be an arterial? 1. Yeah, 1. Because I already mentioned it with the explanation, right? So this table shows you the design speeds and according to the type of terrain and speed or traffic volume. Okay, so if you know the type of facility and the traffic volume and the terrain, you can decide the design speed from this table. And again, depending upon the type of road, the design speed and the terrain, you can decide the gradient as well. So for example, you're designing a local road, rural local road, which can be a class 2 2-lane highway. Okay, and you want to provide a speed of 40 miles per hour, and your terrain is mountainous. Then you go to mountainous terrain curve. This is a curve for mountainous terrain, and then you select the gradient from here. Okay, let's say you are designing rural collector and your terrain is rolling and your speed is 50. So you come here, 50. Rolling terrain is this curve. So you come to this curve and you select the gradient from here. Okay, and same thing can be done for arterial as well. So these are some design standards. We are not going to use them in the analysis, but just for the sake of explanation, I've included them in the slide so that you know the difference between the types of or the classes of two-lane highways. So we start with the value of the capacity. First of all, you should know the capacity of the two-lane highways. The capacity is fixed 3,200 passenger cars per hour for both directions. And when, like I mentioned earlier, when you have one direction completely saturated, it will affect the other direction. Okay, so this 3,200 is not equally divided in both directions. So you can see here, out of this 3,200, only one direction can have 1,700. The other direction will have 1,500 at the same time. So if one direction goes up to 1,700, the other direction will not go up to 1,700 because it is getting affected by the other direction. Okay, so if there was no effect of one direction on the other, then both of them would have had 1,700 passenger cars per hour and the total would have been 3,400. But since one direction affects the other direction, so one direction can go up to 1,700 at the same time, other direction can only go up to 1,500. Okay, now this is capacity under base conditions. So let us define the base conditions like we did for multi-lane highways and freeways as well. So base conditions, most of them are same for freeways and multi-lane highways and two-lane highways. Lane width, the standard value is 12 feet. It can be more than that. Lateral clearance should be 6 feet at least, base conditions, okay? And lateral clearance includes the shoulders. Lateral clearance includes the shoulder as well. It should have level terrain, no heavy vehicles, 100% passing side distance is available. So on all points of the two-lane highway, passing side distance is available. This is a base condition. Okay, so when we don't have passing side distance available on any particular part of the highway, we make that part as a no passing zone. As a no passing zone. So no passing zone, in our case, you will see it with a solid white line. Between the two lanes, you will see a solid white line. That means no passing allowed. You cannot go to the other side. And they also make a triangular sign like this. I do not remember the sign completely, but it has two cars on it and it has, you know, two lines on it to mention that passing is not allowed. Okay, so these are the two indications which we use for no passing zone. A solid line between the two directions and this triangular sign with it. Okay, so why do we make a part of the highway as no passing zone? Mainly because of side distance. Side distance not available, that part will become no passing zone. Okay, and vice versa. So if side distance is allowed or side distance is available on all points of the highway, then the complete highway will not have any no passing zone. Okay, if side distance is available throughout the highway, then no passing zone. Then you will not have any no passing zone. Okay, and vice versa. If the side distance is not available on any point of the highway, then the complete highway will be a no passing zone. Okay, so the base condition is side distance available on all points. 50-50 directional split in the peak hour, again base condition, and no interruptions. Okay, now again a reminder, when we say no interruptions, we basically mean no interruption within the 2-mile range. Because if you remember in the last chapter I told you multi-lane highways and two-lane highways have interruptions, but these interruptions are 2 miles from each other. So the segment between the interruption can be considered as uninterrupted. If you want to calculate level of service for a two-lane highway, then you may need some of these factors. What are these factors? ATS, average travel speed. This is the average speed of vehicles in the peak 15 minutes of the peak hour. Average travel speed of vehicles in the peak 15 minutes of peak hour. That is ATS. Then we have percentage time spent following, PTSF. PTSF stands for, PTSF means the percentage of peak hour in which the cars had less than 3 seconds of headway between them. Okay, what is the logic of that? When there are two vehicles which have less than 3 seconds of headway between them, that means one car is following the other car. Following means its movement is dependent upon the movement of the car in front of you, in front of it. Okay, so when the front car slows down, the rear car will also slow down. If the front car stops, the rear car will also stop. If the rear driver wants to accelerate, he cannot do it unless the front driver also accelerates. Okay, and this happens when the headway is less than 3 seconds. So when your headway is more than 3 seconds, you still have some flexibility to take your own decisions. You are having less impact of the front car on you or the front vehicle on you. But with the headway is less than 3 seconds, you are completely dependent upon the front vehicle. Okay, so percentage time spent following is the percentage of the peak hour in which the car in front of you has less than 3 seconds of headway with you. Okay, and then the last thing is percentage free flow speed, PFFS. PFFS is a ratio of ATS and free flow speed of the highway. Average travel speed and free flow speed of the highway. Their ratio is called as PFFS. Okay, now let us see how we can calculate or find out level of service using these parameters. So first of all, you need to know the class of the freeway, the class of the two-lane highway. If you are doing the analysis for class 1, then you need ATS and PTSF both. If you're doing the analysis for class 2, then you only need PTSF. If you're doing the analysis for class 3, then you only need PFFS. Okay, and then you can see the ranges and the level of service. If you're doing the analysis for class 1, then for example, your ATS is 52, so in this range, and your PTSF is, let's say, 40, so in this range. So your level of service is B. Simple. But what will happen if your ATS is in this range and PTSF is in this range? For example, your ATS is 52 and your PTSF is, let's say, 55. Okay, so one value is here, the other one is here. Then you will take the lower level of service. Okay, so for a level of service, both values must be in the range of the same level of service. If this doesn't happen, then you will take the lower value. So one value is in the range of B, the other one is in the range of C, you will take C. If one value is in A, the other value is in C, you will take C. Okay, so this is for class 1. For all these analysis, we must know the free flow speed, like we said for freeways and multi-lane highways, right? We must know the free flow speed. Free flow speed can be measured in the field. This is something I mentioned previously as well. You measure free flow speed in free flow conditions. What is the range of free flow conditions, or what defines the free flow conditions on two-lane highways? If the total flow in both directions is less than 200 passenger cars per hour. If the total flow of both directions is 200 passenger cars or less, these are considered as free flow conditions. Go to the highway, collect speed data from any direction, that will become your free flow speed. Go to the highway when the total flow is less than 200 passenger cars or equal to it, and you measure the speed from any direction, that will become your free flow speed. Okay, so for measurement of speed, you don't have to collect it from both directions. From any direction is sufficient, but the total flow at that time for both directions should be 200 passenger cars or less per hour. Let's say you went to the highway, you are in a hurry, so you cannot come at any other time, but at that time free flow conditions do not exist. So you measure the speed in flow when the flow is more than 200 passenger cars per hour for both directions. Okay, so that speed will be termed as SM, and using SM you can still calculate free flow speed. Okay, so either you measure the speed in free flow conditions directly, or you measure it in some other conditions and calculate it using this equation. So SM is the condition, the speed in the condition when you measure the free flow, when you measure the speed, and this is not free flow speed because the flow is more than 200 passenger cars per hour for both directions. And then you need VF and you need FHV as well. Now FHV stands for what? FHV is the heavy vehicle adjustment factor. We all know that. We have used it previously. And VF is the observed flow rate when you were measuring the speed. What was the flow rate in vehicles per hour when you were measuring the speed? That is VF. And FHV is the heavy vehicle adjustment factor. If you cannot do any measurement, if measurement is not possible at all, then just use the equation, this equation. Okay, so we have three options to find out free flow speed on two-lane highways. Measure it in free flow conditions. Measure it in some other conditions and then calculate free flow speed. Or just use this equation without any measurement to calculate the free flow speed. Okay, so in these equations, the factors are almost the same, which we have already used. BFFS means base free flow speed. FLS means combined factor for lane and shoulder width. FLS means combined factor for lane and shoulder width. And FA is the factor for access point density. And access point density is calculated by counting the number of access points on both directions of the highway and then divided by the length of the highway. Okay, access points, I defined it for multi-lane highways as well. Unsignalized entry points. Entry points which are unsignalized in any direction of the highway for two-lane highways. So you count how many of these points you have, how many of unsignalized entry points on the highway you have, and you divide by the length of the highway. That will give you access point density, and then FA will be taken according to access point density using this table. So this is a table for access point density, and this is a table for lane combined factor of lane and shoulder width. Okay, combined factor of lane and shoulder width. Let us do a very small example here for calculation of free flow speed, two-lane rural highway, rolling terrain, lane width given, shoulder width given, access point density 30 per mile, base free flow speed 60 miles per hour. Okay. Now there is no measurement of speed is given. That means I have to use this equation without any measurement. Okay. So this is the equation. Let me go here. Okay, so free flow speed equals base free flow speed minus FLS minus FA. Base value is given 60. Okay, if you don't know the base value, some ranges are given. Okay, according to the class of the highway, some ranges are given. Class 1 highway has a range in this, class 2 highway has a range in this, and class 3 highway has a range in this for the base value, BFFS. Okay, in this case it is 60, so maybe it's class 1 highway, so 60 minus the combined factor of lane and shoulder width. Lane is 11, shoulder is 2. So 11 means here and 2 means this one. So your factor is 3. Okay, so minus 3. Then access point density, 30 access points per mile. 30 is this one. So your factor is 7.5. And again, if you don't have a value which is given in the table, then you can interpolate. So if I give you a value 25, you can interpolate between 20 and 30. Okay, no problem. Interpolation is allowed. But here I have exactly 30, so it is 7.5. How much is it? How much is the free flow speed here? $49.5. Okay, so this was a very simple set of calculation for calculating the free flow speed. Okay. The next thing after calculating the free flow speed, the next thing you do is calculate the flow rate, VP, like we used to do for multi-lane highways and freeways. So VP is denoted with small v here. So you need the volume, you need the peak hour factor, you need the heavy vehicle adjustment factor, PHF, FHV, and then we have another factor which is FG. Okay, now number of lanes are not here. Why? When we were calculating VP, we were also dividing with number of lanes. Why are we not dividing with number of lanes here? What's the reason? Huh? Why are we not dividing the volume with number of lanes? N. We were doing it fixed number. What fixed number? What is a fixed number? Tell me. What is it? 2. So I should divide by 2, right? Should I divide by 2? Only one lane. Yes, Haya. Only one lane. Yeah, one lane. Basically dividing by 1 here. We're basically dividing by 1. 2-lane highway. So volume for each direction has 1 lane. Okay, so this is volume for each direction. It has only 1 lane. So you are already dividing by 1. Okay. So N is not here because N is 1. 2-lane highway. N is 1 here. And we have another factor which is gradient. Factor for gradient. Okay. For this we need to see some tables here. Okay. So the factor for gradient depends upon the flow rate. Okay, flow rate means volume upon peak hour factor, and it depends upon terrain. Okay, and it depends upon what are you trying to calculate in the end. Are you trying to calculate ATS or PTSF? Okay, so grade adjustment factor FG depends upon flow rate, volume upon peak hour factor, terrain conditions, and the parameter you are trying to calculate. If you have level terrain or if you have downward gradient, then your life is very easy. The factor FG will be 1 for all cases, no problem. Okay. If you have rolling terrain, then factor FG for calculation of ATS will be taken from here, and FG for the calculation of PTSF will be taken from here in case of rolling terrain. Okay. If you have upward gradient, so level and downward gradient factor is 1. Rolling terrain, you have a column for ATS calculation and you have a column for PTSF calculation. If you have upward gradient and you want to calculate ATS, then you will use this table. Okay, so in this table you need the value of gradient, you need the length of the gradient, and you need the flow rate again. So flow rate again, volume upon peak hour factor, and you will get the value of FG from here. And if you want to calculate PTSF and you are trying to find out FG for calculation of PTSF, then the factor will be taken from here, and again you have the same parameters: gradient, length, and flow rate. So in all tables you need flow rate, V upon peak hour factor, volume upon peak hour factor. Okay. So I will stop here. We'll do some. We'll look at some more equations, and inshallah do some calculations as well on Sunday. Any questions? Any thing you want to ask me? Is it clear? Everything is clear?
Doctor, when are you posting the grades for test 2?
I don't know.
Okay.
Okay. Anything else? Okay. Have a good weekend. Maybe after the weekend I will try. Okay. It's good, you know.
Yeah. Thank you, Doctor.
Yeah. I think the good students are only, there's one good student in the other section as well. She also keeps on asking. And when I say I will take time, she said no problem. She's just making sure that the weekend or any holidays are not ruined because of the grade announcement. Okay. So I think this is the strategy, right? The grade should not be announced before any holidays or before any vacations. So I will try to make sure that I, follow you. Okay. So everything is clear then. Thank you. Have a nice weekend. Enjoy if you can, as much as you can. And I will see you on Sunday, inshallah. Assalamu alaikum.